And the more I've learned, the more I like about energy recovery. The concept is really simple. You got to build tight and then ventilate right. So in the summertime, you're using alternating channels and layers. This is the primary way that I've done this in my career, is using cross flow enthalpy plates. We also do some work with counterflow enthalpy plates. You can use sensible plates as well. I should say enthalpy is when you recover both the heat and the moisture from the air. And then the sensible is just recovering the heat from the air. But what you're doing is you're using the outgoing air from building to precondition the air coming into the building. So that air, you're saving the energy that you're exhausting from the building and using that energy to warm up or cool down the air that's coming into the building. So the end result is you get healthier indoor fresh air in a way that's really energy efficient. The technology's been around for a while now, but it's really becoming a lot more prevalent. But people, they started really increasing the insulation of buildings to increase the energy efficiency of buildings. Then people started getting kind of sick, and they weren't all that healthy inside. The air quality just wasn't that good. So they wanted a way to make the air quality a bit better, have the occupants feel a little bit healthier. But if you just exhaust that air and bring in fresh air without having any kind of exchange of energy, it's really an inefficient process and kind of obviates all the benefits that you're getting from increasing that insulation. So using an energy recovery device allows you to save a lot of energy while providing that indoor fresh air. There's a couple different ways of doing energy recovery. One of the ways that we work with and we see the most, especially in the residential space, is using cross-flow fixed plate exchangers. You can also do counterflow, which is cross-flow is a square shape, counterflow is a hexagon. And that's just using alternating channels and layers, with the outgoing air crossing through one layer and the supply air crossing over another air. And through the alternating channels, there's an exchange of energy. Another way you can do this is with a wheel. That's a technology that I've never sold, but that's with a wheel that spins from the outside air through the supply air. There's also, you can use a glycol loop. And all of these technologies have their place in different applications. Of course, I sell fixed plate exchangers, so my bias is towards that particular approach. But yeah, there's a few different ways you can do it. So again, the most common ways we see are probably fixed plate. Wheels are huge, particularly for larger CFM applications. And then you would want to use a glycol loop, which uses a refrigerant cycle for applications where you can't have any kind of crossover there. So you think of like hospitals,